Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're talking about the discriminant and quadratic graphs. Let's start with something you already know and to remind you about the discriminant. Now, when we were solving quadratics of the form ax squared plus bx plus c equals 0, we derived what's called the quadratic formula, which is here. And we found that this expression underneath the square root, we gave it a name called the discriminant, and we found that depending on what type of number that was, whether it was a positive number, negative number, or a number that was equal to 0, it told us something about how many solutions our original quadratic had. I want you to pause the video and see if you can remember the three cases. If b squared is subtract 4ac is bigger than 0, how many solutions do you get? If it's equal 0, how many solutions? If it's less than 0, how many solutions? Pause the video and double check you can remember that. Well, you should have remembered that if the discriminant is bigger than 0, you get two real, and real means on our number line we're used to, distinct solutions. Okay? For example, you might get the answers x is 3, x is negative 3. Now, if b squared subtract 4ac, the discriminant, was equal to 0, you get the same repeated solution. You might get something like x is negative 3, x is negative 3. And if b squared subtract 4ac was less than 0, you got no real solutions. Why was that again? Well, if this expression here was negative, so far we don't know how to take the square root of a negative number. It's certainly not a real answer. It's not on our number line. So therefore, they were our cases. And we're going to use that and link to the idea of how quadratic graphs look. So let's do that now. So, suppose we had some general quadratic, y equals ax squared plus bx plus c, and we were trying to find its roots, or its x-intercepts. Remember, its x-intercept, or its root, you solve by letting y equal 0. So you're trying to solve 0 is equal to ax squared plus bx plus c. Now, you can solve that via a variety of means. You could do that by factorizing, completing the square, or solving the formula. But one thing you know is true. You know that if b squared subtract 4ac is bigger than 0, you're going to get two answers. If it's equal 0, you're going to get one answer. If it's less than 0, you're going to get no answers. And I've tried to draw in the pictures here for you to help you understand that. Here we have two x-intercepts. Here we have two x-intercepts, or two roots. These are the two cases where b squared subtract 4ac was bigger than 0, because it gave us two roots, or two x-intercepts. This was the case here, where I get one repeated solution to this quadratic, i.e. the quadratic just touches the x-axis. It has one repeated x-intercept. So b squared subtract 4ac in this case is 0. And in this case, look, sometimes quadratics don't have an x-intercept. This one does not cross the x-axis, nor does this one. So this must be the scenario where b squared subtract 4ac is a negative number. And there you go. It's pretty cool to think that what we've learned in our algebra also links nicely to the graphs. So, in particular, if someone's asking you, for example, to state how many roots this has, you could quickly work out the discriminant. If it's positive, you can say it's got two roots. If it's equal to 0, it's got one root. If it's less than 0, it's got no roots. Okay, so that's exactly what we're going to do. You might want to pause the video and have a go at this yourself. Now, all the question asks us is how many roots or x-intercepts do the following quadratics have? It doesn't ask you to draw them and work them out, just how many. So all you've got to do is you've got to say that in this case a is 4, b is negative 12, and c is positive 9. And we're going to work out b squared subtract 4ac. That's going to equal negative 12 squared, take away 4 multiplied by 4 multiplied by 9. Now if you work that out, negative 12 squared is 144, and then 4 times 4 multiplied by 9 is also 144, so you get 144, take away 144 is 0. Therefore, you know something very special. Therefore, because the discriminant is equal to 0, you know that the equation 0 equals 4x squared subtract 12x add 9 has one repeated solution. And what does that mean in terms of the graph? It means that the graph only touches the x-axis. So how many roots does it have? It has one repeated root. And we're done. What about the next one? Well, in this case, we're going to say that a is equal to 1, b is equal to 3, c is equal to 5. We're going to go off here and work out b squared subtract 4ac, which is going to be 3 squared subtract 4 multiplied by 1 multiplied by 5, which is going to be 9 subtract 20, which is negative 11. Now, because b squared subtract 4ac is negative, you know for sure that when you're solving the equation 0 equals x squared add 3x add 5, it's got no real solutions. Therefore, this graph does not cross the x-axis. So the question, how many roots or x-intercepts it has, therefore 0 roots. Next one, same old stuff. A equals 2, b equals 3, c equals 5. And you go off here and you work out b squared subtract 4ac, which is going to be 3 squared take away 4 multiplied by 2 multiplied by 5, which is going to be 9 multiplied by 40. Again, you're getting a negative answer here. You're getting negative 31, and therefore you can state that you have 0 roots. And the last one, you've got here that a is equal to 1, b is equal to negative 6, and c is equal to negative 2. So let's work out the discriminant, b squared subtract 4ac, which would be negative 6 all squared, subtract 4 multiplied by 1 multiplied by negative 2. And that's going to give us here 36, and 4 times 1 is 4, times negative 2 is negative 8, subtract negative 8 is like adding 8, so therefore this gives us 44. Therefore, because it's positive, we have 2 distinct roots. Okay? Now that's pretty much it for this particular skill, other than one tiny little problem solving at the end. Let's have a go at this slightly different type of question. Given that the quadratic y equals x squared add 7x add k, so k represents the number usually at the end of the quadratic, we're just not told what its value is, has one repeated root, find the value of k. Now, because this is a quadratic, and you know for something to have a repeated root, its discriminant must equal 0. So the first line of working, you must state that the discriminant b squared subtract 4ac is equal to 0 as there is one repeated root. That is what you've gleaned from the question. Now, all you've got to do is state a, b, and c. A in this case is 1, the number there. B is equal to positive 7. And c is just this unknown number k. You know, usually that might be the number 10 or whatever, and you'd know it. They've just told you in terms of algebra. So c is this unknown number k. So let's work out b squared subtract 4ac. That's going to be 7 squared subtract 4 multiplied by 1 multiplied by k. And you know that's equal to 0. So that's 49 subtract 4k is equal to 0. Now, they've asked us to find the value of k that makes it have one repeated root. So all we've got to do is solve this equation to find k. So let's subtract the 49 off both sides. And we'd get ourselves that negative 4k is equal to negative 49. And divide both sides by this negative 4. So k is therefore, well, a negative divided by negative is overall positive, and 49 over 4, we can leave our answer like that. And that's it. We found this k. When k is that number, the discriminant is equal to 0, and hence the quadratic has one repeated root, and hence we have done the question. And that's it for this skill. Thanks loads for watching.